Assalamualaikum, hello and good afternoon. Today we are going to present a mini project presentation for subject EKT 318 Morden Control System. Our group consists of 4 members, namely Jastine, KANESEN, Muhammad Amir Zakwan bin ALIAS, and YUGESWARY KANESEN. This slide has 5 main contents. They are the introduction, the objectives, our aim, the methodology, and solutions for the problems. This is the question that our group has decided to choose.
Hello everyone, I'm KANESEN from RK20. I will start my presentation with introduction. Filtering on an ECG is done by fourfold, which is high pass, low pass, notch, and common mode filtering. As today's topic is bandpass filter, we all know that the combination of high pass filter and low pass filter, we will get bandpass filter. The high pass filter removes low frequency signal, while for the low pass filter, it removes high frequency signal. Bandpass filters are widely used in wireless transmitter and receiver. The main function of such a filter in a transmitter is to limit the bandwidth of the output signal to the band allocated for the transmission. So I will pass the next slide to the next student.
Hi guys, I am Jastine. For the objective, there are 2 objectives for this project. The first one is to draw the board plot of the system and determine the gain and phase margin of the system. The second one is to design a compensator, lead or lag so that the phase margin would be at least 30 degrees.
The secret of getting ahead is getting started. I'm YUGESWARY KANESEN here, and I'm very glad to be here with y'all today. Now, let's get started. The subject of my talk is on the aim of the project and also the methodology of the project. In the first part, that is the aim of the project, is to design a bandpass filter for heart monitoring system based on the electrocardiogram signal or known as ECG signal, and also to interpret the mathematical equation based on the bandpass filter. Next, I'll go on to talk about the methodology. By entering these commands shown in the slide in Scilab, we will be able to obtain the board plot for the given transfer function, that is, g of s is equals to 5 multiplied 10 to the power of 4 by s into s plus 10 into s plus 100, and we will get 2 graphs of it. The first one will be board plot of magnitude versus frequency. That will be for the gain margin. Now, before we proceed, we will have to know what is gain margin. Gain margin is the difference in decibels between 0 decibels and the system gain computed at the frequency where the phase is 180 degrees. The gain margin is obtained by using phase crossover frequency, and we will get a value of 13.57. This gain margin can also be obtained from the board plot of magnitude versus frequency. Moving on to the board plot of phase versus frequency. That will be for the phase margin. The same case as the previous one. What is phase margin? Phase margin is the difference in degree between the system phase and 180 degree computed at the frequency where the gain is 1. The phase margin is obtained by using gain crossover frequency, and that will give a value of 6.85. Phase margin can also be obtained from the board plot of phase versus frequency. That brings me to the end of my presentation. Thank you for your attention. Now, I'll pass you over to my colleague.
Hello, my name is Muhammad Amir Zakwan bin ALIAS. I'm going to continue the methodology. So, to design a compensator using phase lead network, first, You have to determine the frequency for the new phase margin. Allow 5-degree safety margin for the new phase margin. Secondly, make this frequency our new gain crossover frequency, which is to reduce the gain to 0 decibel. Third, the reduction of gain is 20 log A. From here, we can determine the value of A. Fourth, put 0 1 decade below. Therefore, 0 or Z is equal to omega C over 10. Fifth, find tau from Z, where Z is equal to 1 over tau. And sixth, rewrite the phase leg network transfer as GC is equal to 1 plus tau S over 1 plus A tau S. And finally, just add the phase leg network transfer function into the system, which will result in obtaining the desired phase margin. The example is as below.
For this section, we will talk about the solution that we get from applying the methodology to the question that we pick. Solution for part A. By entering the command on the right, both plot of the system can be obtained. And from the command that is highlighted, we can get the value of the phase margin that is 13.57 degree and the gain margin is 6.84 degree. This is the board plot of magnitude versus frequency that we can obtain from the command. And this is the board plot of phase versus frequency.
I will continue the presentation of part B. To design a lag compensator that the phase margin would be at least 30 degrees, 5 steps are needed. The first step is to determine the frequency of new phase margin and new gain crossover frequency. 30 degree need to be added with 5 degree for safety purpose to get 35 degree, which is our new phase margin. Based on the board plot, our target is 35 degree. So we need to take negative 180 degree plus 35 degree is negative 145 degree. The new gain crossover frequency is 1.802 Hz, or convert to radian per second, we will get 11.322 radian per second. Next, for step 2, to determine the value of alpha, based on the magnitude graph, for 1.802 Hz, we will get 9.262 dB as our gain. By using the formula 20 log alpha equal to 9.262 dB, the final value for alpha is 2.905.
Next, for step 3, determine the value of Z. Put 0 1 decade below the new gain crossover frequency, that is Z equal to 11.322 divided by 10, and the Z value will be equal to 1.1322 radian per second. Step 4 is to find tau from Z, where Z is equal to 1 over tau. That we can get tau will be equal to 0.883. And for the final step, step 5, is to rewrite the phase leg network transfer function as the given below. After that, we add the phase lag network transfer function into the system, which will result in obtaining the desired phase margin. The overall system phase margin is equal to 31.17 degree. That is almost equal to 30 degree. That is, it please the requirement of the design lag compensator.
I would like to end this presentation with a saying from Chris Collison and Geoff Parcell. You can't manage knowledge, nobody can. What you can do is to manage the environment in which knowledge can be created, discovered, captured, shared, distilled, validated, transferred, adapted, and applied. Thus, that concludes our presentation on how to design the bandpass filter for heart monitoring system based on ECG signal. Thank you for listening.